Good morning, everybody. Welcome to the Friday morning West Coast time space show program. I'm your host for the day, David Livingston. Thank you very much for tuning in. We have an hour format today, so I will make announcements at the end of the show after our guest has left, because I want to give most of the time to Melodie to talk. That's why we invited her back to the space show. I will just say, coming up on the space show, we have a special open lines program, and I'm going to open it to the general public on Zoom. But what you will need to do because of Zoom security rules, so I don't get busted again, is if you want to participate, email me and I will give you the passcode and the meeting ID to join, or the phone numbers if you're joining by phone numbers. I can't publish those, or somehow Zoom security finds out about it and then I get nasty emails. But I am going to open it up to the public, and I will be promoting this on the Spatial website and Substack. So hopefully you can join us for a Open Lines 2025, 2026 discussion. And the rest of our programs you can read about on the newsletter. I don't want to take time to go through that. Um, to introduce who's with us today, Dr. Benaroya from Rutgers, John Jossi, our space settlement guru, John Hunt's our physics advisor for the space show, and I'm happy to bring back our guest, Melodie Yashar. She is a space architect, a technologist, and researcher. Um, she has her full bio is on the space show website, so I'm not going to take time to read it. But she was with Icon, um, and she was working on 3D printed homes and structures for the moon. She has now decided to go to Mars rather than the moon. So we'll talk about the transition from moon to Mars. But Melodie, welcome back to the space show. And for all of our new listeners and viewers on our different formats, what drove you as an architect to space architecture, and how did you do that? Because architectural schools don't really do much on space architecture, if anything.
Thank you, David, for the introduction, and it's great to be here. You're absolutely right. Traditional terrestrial architectural schools and programs it don't cover the notion of space architecture, nor should they, frankly. But something really interesting has transpired in the last several decades, particularly with the rise of commercial development in LEO, which is that there's a lot more interest in creating spaces and I would say hospitality focused spaces for a new type of spacefarer, potentially a tourist, potentially a citizen astronaut, let's say. And this has really broadened the understanding of what space environments can be, from being, something more akin to the ISS, which is a essentially a research laboratory, to being more of a habitat, something which could be a long-term hotel or a long-term, let's say, just a more generalized space that anybody could visit. And so there's been a lot of interest in the last, I would say, decade in commercial companies in particular who are looking to architects, looking to designers, industrial designers, as well as spatial designers, to introduce a new sense of space within space vehicle interiors. And so it's really unprecedented. But for the first time, you have Sierra Nevada, Blue Origin, and many private aerospace companies looking to architects and looking to designers in particular to introduce these human-centric environments that can be appropriate for future visits to Leo and beyond. My trajectory into space architecture was an unusual one. Over a decade ago, some of my former graduate colleagues and myself competed within a NASA Centennial Challenge for a 3D printed habitat on Mars. We did this on nights and weekends. It was purely a passion project, and were extremely successful in multiple phases of the competition. I, at that point, got much more involved in large-scale additive manufacturing. I collaborated with a number of private companies who were interested in the transfer of technology from Earth-based additive manufacturing to space. And so we started looking into the material implications, the technology implications of doing so. As I said, we were very successful in the competition. And then that, in a very organic way, led to multiple consultancy projects, both with various NASA centers, NASA Marshall, NASA Langley, as well as private aerospace companies, looking at the potential of introducing space architecture interiors and environments um, that can be suitable, in the near term, in the near future. I would say that there was a particular emphasis on LEO and also on moon-based surface habitats. And so that practice, I would call that an applied research practice, was referred to as space exploration architecture. Um, Around that time, I started doing more research in the relationship of astronauts and autonomous systems. I wrote a research grant for TRISH, the Translational Research Institute for Space Health, which led to a full-time role at NASA Ames within human systems integration. And I was able to merge my architectural background and the work that I had done in the private sector as a consultant and as a researcher with some of what was happening in-house at NASA, so to speak. And so we looked at the relationship of how crew members will operate in a more Earth independent environment with autonomous systems, be that environmental control systems or construction types of robots or apparatuses. I did quite a bit of work and research looking into research analogs, analog environments, and we did some work with the Human Research Program, uh, investigating what crew behaviors will be like on several experiments in Hera and in Nemo, these analog environments. And I was there for a number of years, and around that time, I was introduced via a mutual customer of ours at NASA Marshall to Jason Ballard, who was the CEO of Icon. And I was pretty convinced that I was set to work in aerospace for the rest of my career, but he made a very convincing argument that I could merge my past architectural experience and career trajectory with what they were doing at Icon, which was commercializing large-scale additive manufacturing for the housing industry, while also applying the technology for lunar applications. And so I was a very early employee at Icon. I started a department there where we hired architects, engineers, designers, research scientists, and we developed the technology and really commercialized it. And I think to this date, there is no other company who's delivered more large-scale additive manufacturing, large-scale 3D printed structures for the housing market, or who has made as much progress looking into in situ additive manufacturing on the moon. So that's a bit of a history for me as to how I got into the topics that I do my work in. And I can speak to how this relates to some of the work that Inara is doing now as well.
I remember a 60 Minutes program on Icon, and you made it on the
Yeah.
program for about 2 minutes, I think. But is it was it on the job training to adapt how you design things, like if you're going to design a house or an office building or a shopping center, whatever your architectural specialty was going to be? Is it on the job training to try to do this for space, or is there enough factual knowledge that you can actually design in space and make spaces and uh, all sorts of things that are actually realistic and work for astronauts or for people who may want to travel to the moon or someplace just for a joyride or for a vacation? Is it factual enough that you could actually design that, since we're not on the moon, and and we didn't do that when we were on the moon, and so there is no real life experience other than on the space station, I guess. So is it on the job, or is there enough real data that you can do this accurately?
I would say that when it comes to using evidence-based principles for spatial planning and environmental design, certainly there's plenty of research to consult, and we can look to lessons learned from the ISS to make improvements and to use our best judgment for how it is that we make trades when we're designing environments. But on the technology development side, particularly related to additively manufactured structures, we are a far way away from being able to know what works and what doesn't. There are so many open questions. There are so many research gaps that we need to close to really go from the subscale testing, which has been ongoing, and financially feasible for, I would say, the last decade, to something which is structural in nature and engineer something on the scale of a civil structure that can be pressurized and certified for human occupancy. There is a lot of work to be done before we can confidently say we know exactly how that will happen and how it should happen.
So we're not on the moon yet. We don't even have a habitat for, Artemis crews later on.
Mhm.
And we don't have anything orbital other than some new space stations that are supposed to be coming up.
Mhm.
Not sure if you're working with any of those or not. And now you're moving from the moon to Mars, but we haven't even gotten to Mars. We have no space settlement yet. So um, I guess I'm trying to find out um, how do we get something for people, maybe not highly trained and physical fitness gurus, that's going to work? How far away are we from that on the moon, or maybe orbital, like a O'Neill colony, but maybe smaller, because I don't think space manufacturing could make an O'Neill colony today.
Mm.
And other than Elon Musk, most people say Mars is pretty far away.
Yeah.
Musk is still saying, he's going to take the whole world up there pretty soon. So give us a realistic view, and why did you move from Moon to Mars? And then it's open for anyone else who wants to discuss or ask a question or comment.
It's a great question. Certainly didn't move from Moon to Mars because it's easier. That's for sure. The we don't like to prognosticate, when we think things are going to happen in space flight, but the date, or I would say the rough range that we're sort of assuming for this concept that we've put together for a 3D printed Mars habitat is around 2075, 2080, and no sooner than that. So myself and a highly interdisciplinary group of collaborators have recently been working on a commission for a Mars habitat concept, which is going to be constructed at scale, or a portion of the habitat will be constructed at scale, and exhibited as part of an aerospace exhibition later this year in October. And the one of the questions that was posed to me, I had spoken with Corky Clinton, who was the head of the Moon to Mars Autonomous Construction Technologies program, which Icon was one of the key contributors to. And he told me, we don't have a clear way, even for the moon, let alone Mars, to to interface 3D printed structures with soft goods, which are being planned for deployment on the moon today. The Artemis Foundational Surface Habitat team has a tin can habitat that's 2 stories that's currently being planned for initial surface missions to the moon. And they're very curious, very interested in how we can not only integrate soft goods and inflatables with that structure, but also in the future, additively manufactured structures. So this became a premise for the project, so to speak, is how can we introduce 3D printed structures that can one day integrate with both hard shell structures as well as soft goods and inflatables. And the even though I'm working on a Mars project that can be anticipated to take place or be constructed in 2075, 2080, the concept itself of introducing an additively manufactured structure that integrates with soft goods and with hard shells is also applicable to the moon. So that kind of dual use approach, I think, is extremely important in how we plan technologies and deploy systems both for the moon and for Mars. I really do believe and I subscribe to the notion that the Artemis program is intended to be a stepping stone for Mars, and that a lot of the technologies that we deploy on the moon will one day be deployed on Mars as well. And so, we're doing the hard thing because it's, how can I put it? In space architecture, it's a little bit more forgiving. The further out that you're reaching, like we can sort of suspend disbelief that certain technology systems will be developed within the next 20, 30 years. And it certainly makes for a much more exciting exhibition from our perspective. So, we went with Mars as the kind of context for our current project, but the short story is that we believe the technologies and the systems can be applied to the moon as well.
Two quick questions before someone else gets in. One, do you, and Chaim, this is also for you since you work in the field, do you guys just dismiss what Musk says and his timelines for getting uh, S load of people to Mars in 2030, 2031, 2032, starting with a full starship? Do his claims mean anything to you guys? Because he's not talking about 2075 and 2080. And then I don't know how old you are. I do know how old Chaim is. So we're talking about 50, 60 years from now, given the times you said. So it's unlikely that you're still going to be designing in 50 or 60 years from now. And again, I don't know how old you are, but um, so how do you design for someone to finish your work in the natural process of evolution of you retiring and younger people coming in? That can they, what if something other than adaptive printing, 3D printing comes along in 2050? So you're still 25 years away. Can, is there flexibility and can new people that might take over after you're left the scene or Hyman's left the scene, uh, can they work with what you've done and adapt it? And where will Musk be in 2075? I mean, he probably won't be with us physically, but um, if he starts getting people on the moon, on Mars, do you have to start paying attention to him? Or I don't know. That always has bothered me. How you got a guy out here with money and capability, and everybody else is saying 75 years from now or 50 years from now.
We have to pay attention to that. And how can I put it? I really respect how ambitious those claims are, but the pragmatist in me also knows that we're just so far away from being able to safely say that we can send humans into in transit and to the surface of Mars, given the limited knowledge that we have of the effects of deep space radiation, the effects of being in a microgravity environment as long as they will be, and there's really there's so much that we don't know that would prohibit us from saying that this is viable right now. Even reentry, like how reentry would happen after a 2+ year journey to Mars, I'm not sure. And I think that the sentiment is just about getting there and about maintaining momentum and maintaining a kind of ambition to insist that this must happen rather than seeing the full picture of, struggles and the challenges from a research perspective, which I think that we have to be honest about. Um, that's what I would say. And then when it comes to continuing the work, absolutely. Like there's no way that myself or anyone else can do this work independently or on our own. And this goes back to the importance of publishing and sharing information and being able to and allowing these projects to exist more publicly so that others can pick up where we leave off, because we're certainly not going to address or solve the problem until something is built full scale or tested full scale. Or just not at the point where we can safely say that we know exactly how things will transpire. Some of the research that I'm doing as part of Inara adjacent to this Mars habitat concept that we're developing is looking at robot to robot interaction so that we can really synchronize autonomous operations in a consistent and autonomous way. And frameworks for that are still in very, very early development, both terrestrially and in space. So there's so much in terms of research to be able to contribute to, and I certainly hope that in developing the team that we have, working with younger people younger than me, and making sure that the project can be accessible and available to others in the future, that this is something that can go on past myself and past what Inara is.
Jossie, you had a question?
Well, it was answered. You asked my question for me, David. I see Musk with plans for a city on Mars by 2050. So obviously, he's pushing the envelope there. It sounds to me like it's the it's it maybe it's a combination of budget as well as technical capability that would push out that timeline. If we have billionaires willing to spend the money on R&D, maybe that schedule could be moved up, right? I mean, once Musk needs a habitat on Mars, maybe he's going to come to you and say, here's $1 billion, build me a 3D printed habitat. But we're not there yet, obviously.
You're 3D printing with materials from the moon and materials from Mars. You're not taking up the material. So there's a big assumption there, and uh, maybe Haim as an engineer might comment on it. There's a big assumption there that the materials for you to use on the moon and Mars are going to be structurally sound in your additive process. So just to be a devil's advocate, and I'm not an engineer, so I don't know anything about it. And I've never worked a 3D printer, although I understand you can buy them for your desktop. Um, how do you know that lunar materials or Martian materials are structurally sound and will work? And I don't even know what structurally sound might be on the moon or Mars.
You're pointing to one of the most critical gaps when it comes to, I would say, not only material applications, but future structural applications when it comes to habitats. Um, we don't know. We don't know what in various parts. I mean, let's start with the moon. What the chemical and mechanical properties of regolith are on the moon, let alone on Mars. We're mainly using imaging on Mars to be able to make assumptions, and of course data from the rovers. But Mars sample return is so important for this, so that we can really, really understand what the properties of the regolith are, and then start to anticipate how that might apply to future structures and future civil engineering. But part of what we'll have to do, and what makes this work so difficult, is that you need to arrive to the surface of the moon, verify that the regolith and the properties of the actual soil are what you anticipate them to be, do sampling, do testing, even prior to beginning construction. So, in terrestrial construction and civil engineering, you always plan for contingencies, but there are an exponentially greater number of contingencies that you can and should be planning for when it comes to in-space construction. And that's one of the things that we have been looking at in our project in particular. What do you do if the chemical, or I would say the properties of the regolith, once they're sintered or once they're processed, are not exactly what you thought they would be? What modifications can you make? What are the parameters that you can change to introduce structurally sound building structure, or whatever it is that you're printing? Yeah,
We
so
have we have lunar soil on Earth.
Fortunately, right. I think for the moon, I think we know much more obviously than Mars, and we have a lot of data on lunar regolith and a lot of different simulants and a lot of studies both for 3D printing using lunar regolith, creating structures, how structurally stable various configurations of regolith are. So I think we know, and that's why a lot of us are saying we really have to go to the moon to get a lot of that information, uh, as well as to just be able to learn how to build in that environment. As you were saying before, Melodie, there's just a lot of things that we can only do once we're there. That's true for Mars, but definitely true for the moon as well.
So do you have to, because we have so much information on the moon and we have actual lunar soil on Earth, do you still have to go through all the kind of testing protocols and backup and contingency plans that Melody was mentioning? Or can the lunar process be streamlined and made faster because of what we know already about it?
It will be faster, but it certainly won't be what we can do on Earth. And 3D printing in general is a complex process. The machines have to be serviced. I mean, on the moon, we have all these regolith issues, right, with electrostatic charging, getting stuck on everything. So I think the issue is going to be uh, knowing the process, but also dealing with the environment while having that process go forward.
Can AI circumvent any of this, Melody or Chaim? Can the deployment of AI programs uh, compensate for lack of knowledge or lack of testing, or just do a better job in knowledge and testing?
I think somewhat, even in terrestrial additive manufacturing, there have definitely been, for many years, vision systems that have been incorporated that use machine learning to anticipate anomalies or faults in 3D printed structures. Um, this is especially critical if you're talking about pressure vessels, or we're talking about metal additive manufacturing, where the risks are pretty great. Um, I would say terrestrial construction is a little bit more forgiving, but yes, absolutely. The more data that we have about 3D printed structures, the more we can anticipate problems, particularly when it comes to the material system. I agree with Chaim that the environment on the moon is going to be the most unforgiving. Um, and yeah, how we'll have to send some small scale tests before we launch a habitat scale program, or a large structural program. And that's one of the things that we were really working on at Icon, is how can we send an initial 3D printer to deliver and construct small coupons that can be tested for their material properties on the moon, and then use that as the basis for scaling up construction in the future.
Is the moon a 20 75 timeline tuner, or what would you give a timeline for a lunar?
I think the technologies are available. I think that we're ready to deploy these technologies quickly, frankly. So I'm hoping within the next decade that we'll see construction on the moon, particularly in establishing some infrastructure for a lunar base. I can see that happen even within the next 5 years.
Is there a plan B if 3D printing surprises you and you have problems? What comes after that if it isn't really the best method that you find out some quirk or something? Is there a plan B for another method, or is there another method?
It's a great question, and it goes back to some of what I was alluding to earlier with regard to the foundational surface habitat for the Artemis missions. They're planning for that structure to be a tin can, a hard shell structure, and for eventually for that structure to interface with inflatables and other soft goods. And then for those to one day interface with additively manufactured structures. So I'm a believer that we need multiple redundant systems available, especially if we're talking about habitation, we're talking about um, environments that astronauts can actually be inside of. And so I don't I'm not one of those missionaries who thinks that it's additive manufacturing or bust, not at all. In the same way that we have multiple types and modalities of construction on Earth, there's going to be many types and modalities of construction on the moon and Mars.
So we have several commercial companies that
Mhm.
are already advertising. I think one of them has already said they've started construction, or John Jossie can correct me, but where they have some plan to have an orbiting hotel. I think they said 2 years. Maybe I'm a little off on that. And, I obviously I think that's BS, but it is structures for settlement. I'm going to say settlement more than tourism. Are are we capable of having structures in space for settlement, or is that still a stretch? If one of these companies really is got a hotel that they think are going to open up in 2 years or 3 years.
I think it's much more viable in Leo than it is on the surface of the moon in the next 2 or 3 years. And it's one thing to deploy a structure or a tin can on the surface of the moon. It's another thing to keep it operational. And I don't think that we have the infrastructure available yet for a continued human presence. It's something that we're working towards, but it's going to rely on an orbiting space station. It's going to rely on power. It's going to rely on other utilities and the availability of resources on the surface of the planet. And so there's a lot of question marks that I have when it comes to thinking about how some of the commercial LEO destinations providers, like whether they can transfer their technology to the surface of the moon and how viable that is in the near future. There's a lot of open questions that I have when it comes to that.
Are you working with any of the space station companies that are working for private stations, or with any of the orbital hotel people?
I've been in touch with them, but they're yeah, I've been in touch with a couple of them, and I know some folks who are working at Axiom, for example, space architects and
Uh-huh.
researchers, and I would say some are further along than others.
Have a question. Are you considering just using the material just on the surface that we see like on the moon landings, or you're talking about actually doing any like actual mining where you'd actually go to have more of a vein of particular types of materials that might be useful? How does that play into it?
It's a great question. if we're serious about habitat scale construction, we're going to have to do excavation, mining, regolith processing, and based off of the work that our team has done and the work that Icon has done to really acquire the amount of bulk regolith that would be necessary to actually create a habitat. We are talking about, you know, using a tremendous amount of resources in bulk regolith. Some companies believe that we should be processing the regolith, or I should say, a lot of research indicates that we should be processing the regolith and using, I would say, whatever is wasted for construction. At Icon, we were operating under the assumption that there would be no processing, no beneficiation of any kind, and we would just use the regolith as is. I'm a little bit torn, you know, in our Mars project. We are assuming that we're going to use electrolysis to acquire water from the regolith. We're assuming that there's lots of other processes that we can incorporate to extract resources from the regolith itself, and that it shouldn't just be thought of in terms of construction. So I'm a little bit torn as to like what the most appropriate long-term solution is. This also relies significantly on the infrastructure available on the planet, both on the moon and Mars, to be doing that kind of regolith processing. If you have like a water acquisition technology available, I think we should absolutely be using that on the surface of Mars. But how that relates to or coordinates with construction operations using regolith for habitat construction or landing pad construction or road construction, there's a lot of open questions there that requires further research, I would say.
Hey, Melody, does your research include the use of binders in 3D printing the regolith, or can you do everything in situ? In other words, you know, are you going to have to bring a binder with you to make the material structurally sound?
It's a great question. The work that we were doing at Icon assumed no binders, no additives, no materials brought from Earth. So we were using basically directed energy deposition processes, heat to fuse the regolith onto itself in a process that we were referring to as vitreous melted extrusion. But when it comes to some of the more recent Mars work that I've been doing, we're looking at various materials that would use binders. We're looking at geopolymers and how we can use that to create Martian concrete. We're looking at sulfur concrete, which would also involve the use of limited additives brought from Earth. There's a lot of interest in using polymers on the surface of both the moon and Mars. I know that there are some companies that are investigating polymers mixed with regolith for lunar applications. I'm not sure how that would work, given the extreme temperature swings on the moon. But I think that we have to consider the viability of multiple material systems for different types and applications of structural makeup. So, for example, we can think of personally, I think of habitats in terms of a wall assembly, and we can essentialize the materials that are going to be most needed on the outside of the structure for those reasons, and then the inside of the structure. And so, long story short, we want to be able to investigate as many materials as possible. And if we can manufacture or engineer those materials without additives and binders from Earth, the better. But in some instances, I think that we're going to have to consider how to bring some with us.
So you have been working with Martian regolith simulants? Mars regolith simulants.
We haven't worked with simulants, but we've been investigating what kind of materials we can use assuming the regolith composition in certain areas of Mars. So we started with a very broad survey of what the composition of the regolith is on Mars. Based off of that, did a trade analysis for where the habitat should be located with a certain bias to being close to those construction materials, and then began to investigate, based off of the proximity or, not of those materials, what kind of structure can we create using what processes, and how do we actually process the materials to create a structure of X size. In our case, we were looking at a habitat that was roughly 11 meters in diameter.
And you made certain assumptions about the composition of the Martian soil to create a simulant?
No, we didn't create a simulant. We were using existing research based off of imaging that's been available on Mars or that the rovers have generated. So it's all based off of existing research.
Interesting. So while you were talking about the Mars, sorry, the lunar simulant, I went to Grok and asked the question, has research been done using Martian simulants? And it said yes, and it gave some examples. So I'm wondering if it's hallucinating, or is someone else doing research with the Martian soil simulants? Do you know?
Yeah, there's definitely Mars simulants that are available. I wouldn't say that they're representative of every which region of the planet that we might be interested in inhabiting. There have been so many site selection studies, both by NASA, ESA, and SpaceX, identifying regions of interest for where the first settlement should be. Those are things that we wanted to respond to, in addition to the availability of different types of regolith. So I think that there's still a lot for us to do in that regard. We ended up picking one site which was particularly good for its sulfur and sulfates. But there's lots more work that can be done in this area, looking at how we can leverage ISRU resources on Mars for construction.
So the interior is going to have to be an inflatable, right? Or was the outer structure sufficient to have a breathable environment on the inside?
In our case, for this particular project, we partially pressurized a regolith shell and also introduced an inflatable for that would be fully pressurized.
Melody, I have a sort of a policy question for you. When I was actively teaching at UND, I would bring in guest speakers from the commercial sector and from NASA. I was teaching commercial business courses uh, when there really was very little commercial business. Um, and we'd take surveys of where the students wanted to work when they graduated. So it was like 95% said SpaceX or some of the commercial companies that I brought in. Very few said NASA. And the reason they said that was that they had a real chance to see the projects that they worked on fly or be deployed in a commercial company, and very little chance of seeing that in a working for a government program. So if your timelines for flying stuff, deploying hardware are 50, 60, 70 years out, how how do the needed, talented, essential younger people get inspired to come in there, because they may very well work their entire career and not see any of their work deployed on the moon or Mars.
Mm.
So, and maybe Heim can address that too. Maybe it's not a factor in your departments. I don't know. But I remember, and I know Heim taught my classes a few times at UND as well. And boy, they were really adamant. The commercials gave them a chance to see their projects fly. And that was really important to them.
There's no question that there's so much exciting work happening in the commercial sector, and the pace of development is just um, is so much greater, particularly when you have companies that are privately or self-funded, which is what we're seeing for some of the LEO providers. It's what we're seeing for SpaceX. It's what we're seeing for Blue Origin. So there's a lot of leeway there in research and development and seeing your work fly. There's no question. Um, I don't blame them. You know, I think Icon had a really wonderful moment when we were awarded a phase 3 SBIR, where we really felt like um, there was nothing holding us back. And to this day, I'm convinced that that work is going to fly. The initial construction technology demonstration mission that was planned for a CLIPS lander, I'm hoping will be able to hitch a ride in the next couple of years. And it's just about seeing it happen, you know. And I don't think that there's anything stopping us from seeing that technology deploy, apart from just the logistics of transportation and getting there. And I think that personally, having assembled this team recently with Inara, I see more excitement in young people than ever. You know, I think that the more success that we see from the commercial sector, the more excitement there is in future generations to be able to contribute to some of these more grandiose ideas of in-space habitation, 3D printed habitats, which are not new. You know, like these ideas have been around for many years. And I personally like see myself continuing the work of others before me, Scott Howe, Chris Kennedy, like their careers are prolific in my book, even Chaim as well. And I think that we have to see ourselves as on the same trajectory to make this work possible. It's not like we're working in a silo. Um, to a certain extent, I'm happy for any progress to be made in this regard when it comes to in-space construction, when it comes to ISRU construction for habitats or other infrastructure. Um, yeah, I think it's all good progress.
Do your students want to see their projects fly? Is that a big part of it, or are they happy with progress, or how do you define it or see it?
I think that's sort of more of a personal characteristic. Some may not want to work on something that they don't see the completion, but I think many are also happy just to be part of the activity. Like Melody was saying, you're on a trajectory and you're part of a team that spans generations. And I know that the papers that I've written uh, are just going to seed other people's work, and I'm happy with that. I don't really expect that some of the concepts will transcend to the lunar surface, but I do believe that it's more than specific concepts. I think it's more of a philosophy and a way to approach the problems rather than the specific solutions. So I think, we all build on each other's work. And so I think we're happy with that. And I think also being at a university, we're passing on the information and the ideas to the next generation. And I find that also a rewarding activity.
Uh, do you see uh, well, let me go to this question. John Batchelor, who is my associate and does Hotel Mars, has a favorite question, and he gives the scientists, says, I'm giving you an unlimited budget. What would you do? So, first of all, would an unlimited budget expedite this work and shorten the timelines? And Melody, if there was an unlimited budget in everything that you're doing, what would you do differently to maybe make things happen faster? Or maybe the R&D just really can't be sped up because you need to do testing, you need to do this or that, and it takes time. So does an unlimited budget make a difference? I guess that's the question I'm trying to come up with.
Oh, sure it does. Sure it does. I think that particularly for large scale additive manufacturing, the challenge is going from subscale testing to something which is structural and inhabitable. And that's the case terrestrially, and it will be the case for space as well. So there's no question that an unlimited budget would be able to speed things up. You'll be able to try different methods of construction, uh, try different kinds of, I would say, like site support robotics that can support different activities in construction, excavation, foundations, etc. You'll be able to test how to certify for a pressurized habitat, which is not something that's been really investigated at scale before. And a lot of folks don't believe that you can create a pressurized regolith-based structure that is airtight and that can withstand those internal pressures. So certainly, there's a lot of work that can be done with an unlimited budget.
Yeah, there really are endless problems. I'm still waiting for Elon Musk to donate $1 billion to Rutgers, and I think with $1 billion I can probably create a new campus and start hiring across the fields of space and lunar habitats. And probably I'd run out of money first before I run out of problems to solve.
Melody, a lot of people say the secret to lunar settlement or at least habitats is going to be living in the lava tubes.
Mhm.
So, have you done any work I know Haim has because we've talked to him, but uh, lava tube design, the interior of a lava tube. Have you done anything about lava tubes, and would it need 3D printing, or is that a bypass?
No, I don't think it would need 3D printing. I think there's a lot of living in lava tubes for the purposes of protecting against deep space radiation is extremely viable. I think that makes a lot of sense. Um, it doesn't necessarily solve the problem of how to create a pressurized interior or pressurized environment. So we're still looking to some of the more traditional construction typologies. NASA refers to these as classes of space architecture. The hard shell, the inflatable, and then possibly a 3D printed or ISRU derived structure. So ultimately, the challenges are the same. I think that one of the more interesting problems relative to lava tubes is how do you actually deploy, or how do you actually uh, move and relocate all of the construction equipment necessary down into the lava tube and then back up? Are we thinking about large scale space elevators? These are some of the more interesting ideas, which personally I haven't looked into, but uh, which I think are going to be essential for us to consider when we look at lava tubes.
So I know we're coming close to the 60-minute point. Um, so I mean, this has been a pretty hard-hitting factual discussion, and I'm quite sure some will give us comments that we're also negative, because um, I use the term fanboy, but uh, the groups of people that don't really pay a lot of attention to evidence-based factual things talk about settlement and living in space and going to Mars as if we could do it right now today. I mean, the gap between reality and, I guess, vision, I don't know if vision is the right word, is pretty huge. Um, any,
And we
any,
haven't even spoken about biology,
Mhm.
right? And biology is even harder than engineering.
well, what about our friends, the robots? We haven't mentioned anything about them. Won't they kind of skip biology to do a lot of the work on Moon and Mars, or and so the biology would only be limited to the residents, for example? Um, are we up on robotic technology to accomplish what the two of you have been talking about?
Well, we'd like to do that, but the robots are very susceptible to the regolith problems and their electronics to the radiation problems.
Melody, have you done any work with the robots, and do you plan your 3D printing and stuff to be managed by robots, or uh, I guess on the moon it could be managed by people on Earth because the transit time is really short, but the role of robots seems to be really essential and cheaper probably than putting humans up there.
Yeah, I love this question. When I first started thinking about robotic construction in space, um, I was focused predominantly on 3D printers, but then we started to realize, especially as I was doing work, in large scale additive manufacturing on Earth, that there are so many other types of construction tasks that need robotic input. And in the 80s, there was a lot of research done on single task construction robotics, meaning one robot that would do a certain type of activity, whether it be painting or excavating or um, this is spraying insulation or adding rebar. And that model has drastically shifted towards the humanoid robotics that we're seeing that are so prolific and so appealing that in the consumer electronics industry today. So I'm hopeful and I'm optimistic that humanoid robotics and work in humanoid robotics will be helpful for construction activities in space, but I'm also skeptical for the reasons that Chaim mentioned. We're not really sure how they'll work in that environment, and there's a lot of risks in sending up those kinds of bots in the regolith as well. So I'm not sure, to be honest, but that's one of the things that I'm beginning to look at just in simulation, is being able to anticipate the kinds of construction activities that are going to be necessary and what kind of mechanisms we need to engineer to be able to address those things.
So I'll refer to a real recent segment on 60 Minutes where I think it was Boston Dynamics, is that the company? So they have a human giant robot called Atlas that is supposed to replicate human task. And they were showing, and this is really recent, I think it was within 2 weeks ago, maybe, they were showing what they have to do to get Atlas to be able to do something that a human can do, like turn a wrench, for example. And then they said, we're going to show you what happens. We've been trying for a very long time to get Atlas to do a jumping jack, just the exercise of a jumping jack, and it can't do it. And it falls down and it collapses, and they have to straighten it out and get it to a position where it can recover and come back up. And they said there are so many movements in a jumping jack that a human does to replicate this in a robot, which is like replicating for turning wrenches and for maybe doing a hammer move or something like that, just to show you that this is really, really complex and we're not even close to doing that. We can make them dance, we can make them walk, we can have them run a foot race, but once you start having the robots do intricate movements, even a jumping jack they can't do. And it's now I don't know if Musk is making better progress with his version robots or Sony, but we haven't talked about robot technology. But if we're going to use them for construction on Moon or Mars, we either have to change the way construction is done because the robots today can't really do a lot with human construction. I mean, Chaim, are you seeing that? Or, uh, I mean, if the robot has to imitate human movements to put something together, they're not there yet technologically.
Probably the most advanced would be in the manufacturing plants, where they have automated robots, but they're very specialized and each of them does one very specific thing. in an assembly line. So that's a very clean, closed environment. I think that's probably our most advanced kinds of
Yeah,
robotics.
they took us into the Hyundai plant and they showed the robots, but the Hyundai plant is multiple football fields long, multiple. And then the robots don't look like Atlas or anything like that. And
Right.
it does one thing, it'll attach a door and and that's all it can do. And so um, I can't imagine putting sealed structures on the moon or Mars where the robots are working inside in this pristine environment and having a dedicated robot to do just one thing. I mean, that would be such a massive expense. Um, uh, it probably, I don't know, I can't conceive
And
of it. So how they plan the robots on Moon and Mars for construction is probably a really huge thing. And then the movements they want the robots to do, if they're to imitate human movements, then that is really going to be complex. If there are other movements for assembly, instruction, and construction, uh, maybe they can teach the robot to do something like that. But so I guess if you're relying on robots for a lot of lunar and Martian development, um, that timeline is going to be a while too, I guess.
and the foundation and the basis for success in space is going to be has to do with reliability and maintainability. Everything has to be uh, either highly reliable or it's a throwaway item that you have thousands of. If it's not a throwaway item, you're going to have to maintain it. And robots are very complex, obviously, and as good as they may be, uh, even on Earth, there are a lot of people in that Hyundai plant that are maintaining these robots continuously. They're connected to computers that have certain software that has to work properly. So there's a lot of layers sort of below the surface that has to operate properly in order for what we are talking about above the surface uh, to be what it is, right? To be feasible.
They talked to the Hyundai manager and they said, is this costing you jobs? Are you laying off a lot of labor people? And he said, maybe some people, but we're also hiring people that can service and maintain and control
Right.
and design. So they're really trading jobs, so to speak.
Right.
And it was actually, pretty informative about all of that. So, wow, lots of work to be done. So, what do you say to the people who think we're ready to go today and we should just go do a melody? Uh, what do you say to people that don't visualize the kind of timelines and challenges, or will say we're all being too negative?
Oh, I appreciate the optimism. I don't think we're being negative either. I don't think it's a matter of positive versus negative. Ultimately, I'm a believer. I know that this work will happen. It's just a matter of when and how. The variables are the funding and the capital that's available to invest in these very large, very complex questions, and how quickly we can mobilize once that capital is available. So I don't see it as being pessimistic. I see it as just understanding the forces at work when it comes to realizing these very hard problems.
You're
Hi,
being realistic, right?
Yeah, yeah.
is it a good move to spend public tax dollars on all of this when so many people need so many things here on Earth? That's the proverbial question
Right.
always gets asked on uh,
Yeah.
to space people. How can you spend these dollars to go to the moon when people need medical care here or something like that? How do each of you answer that? Melody, you want to go first?
Sure. I don't see it as being a zero-sum game. I really believe that the benefits that are introduced in advancing space technology and research in space bring back benefits to multiple industries here on Earth. I'm a big believer in dual use development, allowing the work that happens on Earth to support the work that will one day happen in the future in space, and vice versa. It's just not as immediate, you know, the results of that work and the benefits that we see may happen over the course of an entire decade. We're still seeing many products and technologies and economies flourish from the Apollo era and the technologies that were developed then. So it's not an easy answer, and I believe that space will always be an arena and a forum where we can look to the future, remain again positive and remain hopeful for what we might learn in terms of science, what we can develop in terms of technology. And I see it as a very hopeful thing to look forward to in the future.
Chaim, how do you respond to that question, which you
Yeah,
probably
I agree with everything that Melody just said. I think that it is a very positive vision of the future. I think students are attracted to it for that reason. They also see it as something a large thing to become a part of. You know, it's for example, people join the military to be part of something big with a big mission, a positive mission. Space is that way as well. Space really offers almost a limitless possibility of futures. And as Melody said, also, everything that we develop for space will have Earth applications. Many things developed for space can become whole industries on their own. So I think the payback economically is enormous. Plus, it tends to attract the brightest of the students. You know, it's one area where very bright students want to go to. Biology is obviously another one. So, you know, you need a big project, you need a focus, and space, I think, gives that to a lot of very smart people.
My final question, in case the others have a quick one. Will we one day see Yashar Towers and Benaroya Plaza? Will we see structures named after the great founders who helped develop this technology? Do you think you'll see you guys with construction named after you on the moon or Mars? Have you thought about that?
No, never thought about it at all.
Well, we got buildings named after great architects and people and things like that. So why not lunar structures or Martian structures? You know, Yashar Towers, Benaroya Plaza, whatever it is. Melody, have you ever thought about that?
You know, there's a decadal survey that's being put together by the Space Architecture Technical Committee,
Uh-huh.
AIW's Technical Committee, and I've been leading the employment chapter, which is an interesting thing because it's kind of a space architecture employment is still a very nascent area. There's not a lot of employment prospects, but one of the things that we've been discussing is the differences in contracting mechanisms for terrestrial architecture versus what in the future will be space architecture. And I don't think that we're going to be seeing Yashar towers or anything of that sort in space, just because the nature of procurement for these types of infrastructure in space is quite different from the way that licensing and construction happens on Earth. And I think that's for good reason. That's not something that's motivated me.
Uh,
No. And probably if they name anything, it'll be after the people who put the big money into it, like maybe
That's right.
Musk Towers, you know, or Trump Tower too, or something. I don't know, who knows?
either of the two Johns have a final comment or question?
Yeah, I do. Melody, Inara's website looks like it just started. Your mission seems to be agnostic as far as where your work would be done, whether it be on surface settlements or in free space. And I asked you last time you were on about whether you had done any work on architecture for artificial gravity space stations, rotating space settlements. Um, and you mentioned that you talked to Axiom. I know that they're not particularly looking into artificial gravity, but VAST is. I'm wondering if you've talked to VAST about their architecture and their plans for gravity settlements.
I'm familiar with their plan to create an artificial gravity space station, and I think that their roadmap and their, I guess you could say, a stepping stone approach from going from Haven 1 to Haven 2 to eventually an artificial gravity space station is extremely admirable. Um, and what can I say? It's ambitious work, but they certainly have the funding to make it happen. And they're so far they've been hitting their deadlines, and it's such an impressive company to witness, and just in how quickly they've been able to actually engineer and manufacture a lot of what they've been describing up until now.
So I'm on the National Space Society Space Settlement Advocacy Committee, and we're planning the space settlement track for ISDC, which is the first week of June.
Yeah.
Would you like to come down and speak on that track?
Oh, sure, I'd be happy to. I'm planning to come to ISDC, and yeah, I would be happy to.
Okay, I'll reach out to you separately.
Okay.
Unfortunately, I will not be at ISDC because they had the nerve to plan it over my 80th birthday. So I'm not spending my birthday when I turn 80 at ISDC. So how dare they do that? But I won't be there this year. But next year it's in Los Angeles. So um, I'll be driving over for that. Any final comments from anybody? Melodie, thank you very much for returning. We always appreciate hearing from you and look forward to your comments at ISDC. And Chaim, any chance that you'll go down to Washington for ISDC?
I could. I haven't thought about it yet. Are
Uh,
you are you not going to be there, right?
no, I have a surprise. Jossie knows part of my surprise, but he's sworn to secrecy. But for my family and I actually invited him to participate, but he told me he's going to be at ISDC. But no, I'm throwing a little gig for my family. Hopefully, they'll all show up for my 80th birthday.
Why don't
Uh,
you take him to ISDC?
yeah, right. I don't think they would appreciate or find a space conference very interesting. I really don't. So, um,
Anyway,
but
it's good seeing you, Melody.
Good seeing you too.
John Hunt, thank you for being with us. And uh, remember, we have a special kind of open to the public. We'll see if that works on Zoom. Open line show on Sunday. And then you'll see all the rest of our programming on the newsletter. So, everybody, have a great weekend. Do keep looking up. And I'm still hoping to see Yashar something and Benaroya something, probably on the moon faster than on Mars. But people, you guys should get some kind of honor for all of this work that you've been doing. And you could have been doing other things and probably making much bigger bucks. So I think you should be honored. Some kind of lunar structure, but maybe a um, some kind of, well, who knows what they'll find, but possibly keep it in mind. Everybody, have a great weekend. Thank you again,
All right,
Melodie,
take care.
for everybody being with us. Goodbye from the space show.